All right, everybody, let's go ahead and get started. Thank you all for joining today. This is the second of our series of energy code workshops hosting in coordination with the county. This is part of an energy code grant that we received from the Colorado Energy Office. We'll be doing roughly one workshop a month through the rest of 2026. If you missed the first one, we do have a recording of it online. If you go to sustainablechaffee.co, we're going to have all the recordings there. We'll get them on the building department website at some point too, so they're easy to find. We are going to record today's presentation, and it'll be available in the next week or so. But thank you all for those who joined in person and online. If you're online, please mute yourself. If you have a question, feel free to either raise your hand or pop it into the chat, and we'll try to monitor those as we're going or take time for questions at the end, whatever your preference is. Hope. I think without further ado, I'll pass it over unless Chad, do you want to say anything?
No, I think we're good.
Okay, cool. Thanks, Hope. I'll pass it to you to start our presentation.
All righty. Well, I don't believe my screen is sharing, so I will go ahead and share my screen. There we go. All right. Well, welcome everyone. I'm Hope Medina with Shums Coda Associates. I kind of fell into the energy code and never found my way out of it, which is okay because I bring in all the other code experience that I have to kind of make the energy code probably a little bit more understandable and relatable. But today we're going to talk about the compliance paths, which really kind of sets everything up for everything else that we have to be concerned with when we open up that book. So the first thing I want to talk about is how the energy code really determines whether or not a project is considered to be residential and when a project is considered to be commercial, because that lets us know which side of the code book really needs to govern, how we either design to, construct to, gain compliance with as far as the provisions that are found within the energy code. So here is a question. You guys thought you were going to sit there and just listen to me chat, but I believe in having discussions, being very interactive so that we have the opportunity to kind of discuss things. So here's the first of it. When is a project considered to be residential when it comes to the energy code? Now, don't you all, shout it out at once. If you guys all shout it out, I can't decipher anything. So.
I figured out that's good.
Duplex or single family?
Yeah, speak up.
Duplex or single family?
Yes, that does include part of it. So yes, single family, two family are considered residential. Anything else?
Or less.
Oh, I missed the first part.
3 stories or less.
Yes, you have part of it. So R2s, R3s, and R4s that are 3 stories or less above grade plane are considered to be residential. So how it's defined in the energy code, when you find, in chapter 2, definition of residential, is that only for the energy code that it includes the single family, 2 family, and multiple single family dwellings, which is our townhouses. But it also includes those group R2s, R3s, and R4s that are 3 stories or less above grade plane. And then as far as how it's defined for commercial, it is anything that doesn't fall under the definition of what a residential building is now going to follow the commercial provision. So that's incredibly important to know, because there is a very strong possibility that you could be designing and building a structure that you have to follow the building code, the International Building Code, meaning that it's a commercial project, but it is considered to be residential per the energy code. So then you follow the residential provisions of the energy code. Any questions about that? That sometimes trips people up, but all right, perfect. So this really lays down the groundwork for how everything else is going to play out in the discussion here. So one of the most important things to understand when it comes to the compliance path is the sheer fact that this is the very first step in really determining anything, because this is a decision that's made by the designer and the building owner as how they want to design the building to be constructed. It should never fall onto the shoulders of the contractor to determine what we're going to do, because at that point it's too late, because there's all these set parameters that have to be established long before the plans really get into the builder's hands, so to speak. And so something to kind of be aware of is there's a section in both R103.2, which is the residential provisions, and C103.2 that states on your construction plan, so the rolled up pieces of paper, you have to define which compliance path this project is going to utilize. Now, as you can see on the screen, when we're talking about the residential compliance paths, you have some 3 overarching options when it comes to this. You can go prescriptive. Now, within prescriptive, you have options within it. You can go with the U factor, you can go with the R value, or you can go with the total UA. And obviously, we'll dive into that a little bit more. Your second overarching concept is the total building performance. This is where, again, it's just one defining factor, and there's no options within it. You are just doing the total building performance. Now, the last one is your energy rating index, or your ERI option. It's very similar to the HERS path, right? Everybody's heard of the HERS score. They're not one and the same, but the concepts are very similar. Now, under the energy rating index option, or overarching concept, is there's 2 options within it. You can either utilize the path where you are not including on-site renewables into your score, or you're going to include on-site renewables into that score. So this is just a kind of visual concept, because I know a lot of people are visual learners and just getting it visually. So these are the options that are out there when it comes to our residential compliance paths. Now, we're going to dive into these obviously fairly deeply. Otherwise, this would have been a very quick class, right? So let's talk about the prescriptive path, because, up to probably the last few years, the prescriptive path was the compliance path that was utilized the most. Now, as I mentioned, you truly have 3 options in how you're going to utilize the prescriptive path. And that also needs to be expressed very clearly on the plans as far as which option is going to be utilized, because as you can see, each one has different criteria and different potential flexibility that's built into it, depending on which one of these options. So your first one happens to be that assembly U factor. The second one is the R value alternative. And This is probably the option of the prescriptive path that, like I mentioned, was utilized fairly significantly because you just followed what the R values were within the table. Now, prior to the 2021 edition of the IECC, the R value table was the first option of the prescriptive path, and the U factor was the alternative. In the 21, they flopped them so that the U factor was the first option and that the R value became the alternative to that. I know that's a big mess, but the reality is, other than the R value option of the prescriptive path, all other compliance paths are based off of the U factor. So they wanted that to be the first one that's basically seen within the code book. And then the last one is your total UA. Now, I have in here the component performance alternative title to it. And the reason I have that in there is because that is somewhat similar to what it's called on the commercial side of things, and also what this pathway is going to be called in the 2024. And so many people are interchanging the two terminology. I just want to make sure that everybody is aware that if they say the component performance alternative, it's still the total UA. All right. So when we talk about these prescriptive options of the compliance path, the reality is there's really only one difference between any of these options. Anybody have a thought what that might be? I hear some rumblings, but it's not very clear.
There's no clear consensus here.
Oh, okay. Well, good. Then my hearing isn't going bad. All right. Well, I'm guessing you want a hint. Maybe? All right. So here's the reality. The differences between these three options of the prescriptive path is really only how you treat the thermal envelope. So to better explain this concept, we're actually going to kind of dive into what each of these compliance paths are so that there's that understanding of what the basis is and what the differences are for that thermal envelope. So the first one, as I had mentioned, is that U factor. Now, the official title to that particular compliance path is the insulation fenestration criteria option. But basically what this is it's the U factor option of it. Now, how this works is it's that assembly approach. And so what they do is, instead of just focusing on the insulation, they take into account things like your air film, your exterior cladding, your sheathing, obviously your insulation, your studs, your drywall. They take a look at the assembly as a whole and determine how it kind of performs as far as the thermal envelope goes. Now, to determine whether or not something would comply with the code under this option is table R402.1.2 is that governing table that you would utilize. Now, this option is a wonderful option, and I'll explain to you how it's a wonderful option if you thoroughly enjoy doing math. If your joy in life is doing math problems, then this is a great option of the compliance path to utilize, because there is an awful lot of math involved with it, and I'll show you what some of that math could look like for it, just to have that understanding of it. But it isn't really a compliance path option that's utilized very often, and I would say that as anymore, because prior to a few years ago, or a few cycles ago, the concept of that total UA wasn't available. So this was an option of how they would, kind of have a little bit of flexibility as far as the insulation and everything for the thermal envelope. So if we look at our table, R402.1.2, you can see that these are the values that you cannot exceed. So where the U factor table is, everything that's listed in there is the maximum number that you can do. Whereas the R value, it's the minimum number that you can do. And here's a little bit of trivia. So which one do you think came first, the U factor or the R value? And you got a 50-50 shot of getting it right. So you can just shout it out.
R value. Or the U value.
U factor.
Ooh, okay. It seems like there's a little bit of a split there. So what I'm going to say is it was the U factor that actually came about first, and the R value didn't manifest until 1945, and that's because we as Americans, unless you were a golfer, had a very difficult time understanding that the lower the number it is, the better it was. And so in 1945, oh shoot, his name just left my brain there, but he actually created and invented the R value, which is just the inverse of what the U factor is. And so that's why the R value, it's better, and then the U factor is less. Now, anybody know when the U factor was developed? 1701 by Sir Isaac Newton. So it's been around for a while. But next time you have trivia night, you're at the bar and everything, they ask that question, you have it down. You're going to be like, I'm so glad I had that class with Hope because now I get this prize. All right. So as you can see on the screen, here's the table. This is the table that, like I said, governs the maximum that you can be. You can be below these numbers, but you cannot exceed these numbers. Now, how you are able to determine what those numbers are and how to get there is I'm going to show you how a wall is going to be done. So here's a wall assembly. We start off where on the very exterior, we have an air film. That's our paint. Then we have our next layer, which is plywood siding. There it is. And then our next layer happens to be 1.5 inch rigid insulation. Then we have a 1/2 inch wood sheathing. Then we have our R13 batt insulation or wood studs, and I'll talk about that in a minute. And then you have your 1/2 inch gyp and an air film. So this is a somewhat typical, wall assembly. Nothing crazy in it. So now what we do is we take that wall assembly and then we have two columns. We have the R value that we have at the cavity and then what that R value would be at the stud location. And then, so as you can see, this happens to be the second column there is for a 2x6 stud. Because that would have a difference if it was going to be a 2x4 or a 2x6, and I'll explain that in just a moment. So for our first part, our outside layer here is our air film. The R value at the cavity is a 0.17, and then the R value that you get at the stud happens to be a 1.7 because it doesn't change anything with that. Now you'll notice you have the same thing when it comes to the plywood siding, also with the rigid insulation, because that rigid insulation is continuous insulation, meaning there's no framing members that's interrupting it. So you would get that 7.5 at the cavity, and you would also get that 7.5 at the stud. you would have the same value for your wood sheathing. Now, where there is a difference here is when we start talking about that batt insulation or the stud. So at the cavity, our batt insulation that we're installing is going to be an R13. So the cavity insulation value is going to be that R13. Now the R value at the stud is going to be a 6.88. And that's because you get an R value of about 1.13? I could be off, somewhere around there, per inch for your stud. And so as you can see, this is a difference between where those values are. And then our gyp board's the same across. Our air film is the same. And now we have our totals for the two columns. So our R value total for at the cavity is 23.2, whereas the R value at the stud is a 17.08. Now, because like I said, there's a lot of math and fun with this, the next part of the equation is we have to know what the framing factor is. Now, our tradition, or I shouldn't say traditional, but our conventional framing that we are doing now, that it equates to, on average, of having a framing factor of 25%. Now, what that means is that 25% of the wall is framing members. So it could be your studs, it could be your headers, all of that gets into your top and bottom plate, all of that gets into the calculation. As a whole, or thought of it is typically most communities or most people will accept a framing factor of 25% if it's conventional framing. So now what you have to do, and what we have to do is start doing the equation. So for the cavity, we had a total of 23.20. We're going to take that number and multiply it by 75%, because we're saying that 75% of that wall is actually cavity insulation. So 0.75 times 23.2 gives us 17.4. Now we're going to add the equation of 25% by the 17.08. So if we multiply 17.08 by 0.25, that gives us 4.27. When we add those two up, we get a total of a 21.67. So that's what our R value is. But what we need is we need to have that U factor. So now we have to convert that R value to a U factor, which is 1 divided by 21.67. That gives us a number of 0.046. So if we look at the numbers for our U factor, our design, and 0.046, does it meet the criteria for a wood frame wall in any of these climate zones?
No. The answer is no from here.
Yep, you are correct, because remember, we can't exceed the number of the 0.045. So now what you would have to do is go back and redesign it. So the 0.046 exceeds that 0.045. So as you can see, this was a very, very brief, not even crazy detailed, because you didn't even have to go look up the numbers to put in for what the design of that wall assembly is. So as you can see, this compliance path is a little bit of math involved with it. And so the overarching concept for this, right, is this is a compliance path where you are not permitted to do any trading. You can't exceed anything beyond what's in the table of R402.1.2. Everything is going to be by the book, and everything is going to be by the, or on the plans. Now, there is no report that's required to demonstrate compliance with the thermal envelope. You do have to provide documentation of where you got your values for the assembly that you use. So every component of the assembly, you have to say, hey, I utilized, 90.1 Appendix A values, or I went into ASHRAE Book of Fundamentals and I pulled the values from there. Whatever the case may be, you're going to do that. Now, the other thing that you basically have to understand is you're going with whatever the book tells you to do, from R401 through R404, and then you're also going to comply with R408. All right, so that was the fun U-factor compliance path. Our next one, which is probably what I want to say, one that was utilized a lot, and this is the R value option of the prescriptive path. Now, this one is that concept of, it tell me what you want me to do, and that's what I'll do. So the book really leads the way in all of this. Now, for what we have to follow and ensure that we're meeting the minimum is going into table R402.1.3, and that's going to give us our R value options. It still contains U factors for our glazing, but that's because that just makes sense with it. Now, with this particular compliance path, while it is incredibly straightforward and it's telling us, hey, these are the things that you must do, it also contains the concept that there is some built-in flexibility, but that built-in flexibility is only permitted often for this particular compliance path. So it's something to be aware of with that. Now, in this one, again, this is really governing kind of how you're going to address your thermal envelope in it. And what you're going to do is you're going to follow what you have in table R402.1.3 that's based off of what our R values are. And so because it's an R value, every R value that's listed within the code has to be the minimum of what's in that table. Now, you can always go above it, but in this particular compliance path, you can go above it. You just can't trade it off. It truly is, hey, I'm going to do an R75 in the attic. That doesn't mean you get to trade off and not do an R30 in the wall cavity, right? So it is very straightforward, follow A, B, C, D type of deal. So here is the table here. As you can see, for climate zone 6, our first two numbers right here do have a U factor, but that's because we're talking about glazing and we're not talking about the R value, but we still have to know what the maximum U factor is for our glazing. So here are the values for the rest of our thermal envelope assemblies. You can see that, yes, there were some values that increased for this, but it also provided a lot more options in how you want to be able to get there, whether it's, for our wood walls, you could do cavity only, you could do an option of cavity and continuous, or you can just do continuous insulation. So you have a few more options in all of this. Now, the one thing I did want to talk about is the fact that here's an example of where there's some flexibility built into this particular compliance path. And what it has is that if you are utilizing the R value option of the prescriptive path and you are putting insulation into your attic, instead of having to install the minimum, which is the R60 for our compliance or for our climate zone, you have the ability to reduce that R60 down to an R49. Now, to be able to do that, you have to ensure that you are getting an R49 all the way up and over the top plate. So that is going to require that you're going to have those raised heel trusses or energy trusses, because if it's compressed at the top plate, then this option is not available, and you would have to then install that R60. Now, a lot of people say, well, why would they do that and not just have that R49 anyway? But here's here's why they do that. The idea is you have R60 in a traditional no raised heel truss, right? You got R60, and then you have a sloping ceiling. So now you have compressed insulation. So where you have an R60 here, up and over the top plate, you probably have, R28, something of that nature. So the concept is, if you did the area weighted average of it, it would equate to about an R49. So if you can get an R49 up and over the top plate, then you're kind of meeting that intent, and it's just kind of a bonus. Now, another option of flexibility for this particular compliance path is if you happen to have a ceiling that doesn't have an attic for it. A lot of times I see this as the bump outs, right? You have a bump out, you have a reading nook, whatever the case may be. As long you can do it, and you can only install, or you can have it reduced down to an R30, but you can only do it for 20% of the roof or 500 square feet. And it just equates to whatever is the smaller number for that. But these are two examples of where there's some flexibility if this is the compliance path that you utilize for it. Now, for this particular option, the R value option, you're still going to comply with sections R401 through R404 and the R408. And then you're going to ensure that your thermal envelope is based off of R402.1.3, where your R values are the minimum of what you see in that table. Like I said, sections R402.2 is designed for this compliance path to have some flexibility built into it if using the R value option. Now, again, in this option, there's no trade-off for anything in there. Whatever is in the code book, that's what you're doing. And then there's no specific report that's required to demonstrate compliance with this particular option of the prescriptive compliance path. And everything should be placed on the plans for this. Last but not least is our total UA alternative. Now, this is one that I think many builders are utilizing now, and designers are utilizing, because this is the one option that within the prescriptive path that you do get to do some trading of the thermal envelope for it. This is the pathway that is often lovingly referred to as the ResCheck option. So ResCheck is a software that can be utilized to demonstrate compliance with this particular option. Now, it's not the only software. RemRate can do it. Ecotrope can do it. The major difference is typically ResCheck is utilized when the architect is doing it, because ResCheck, or the builders, because ResCheck is a free software, whereas Ecotrope and RemRate are not free, and you go through a process to be able to use it. But so the concepts for this particular pathway is you are going to have two buildings, right? You're going to have that twin building concept, and I'll talk about that here in a minute. Now, table R402.1.2 is utilized to demonstrate compliance through the various calculations. Now, this is very important to understand that only the components that are found in table R402.1.2 are available to be traded. You're going to go into table R402.1.3 for your slab edge insulation and your fenestration solar heat gain coefficient, which for climate zone 6, there is no requirement. So basically the only thing you're going to go into 402.1.3 is for your slab edge insulation. And if you go into res check will not allow you to trade off that insulation. In fact, there's a nice little note that pops up with it, whether you're doing the inputting into the software or you're receiving the report has a note on that. All right, so that twin building concept for it, basically what you're doing is you have your standard reference design building, and that's going to utilize the U factors of the thermal envelope that we find in table R402.1.2. Then you're going to go in and you're going to say, hey, this is what I want to do. I want to put X in the walls, Y in the ceiling, and Z for my windows, right? And as long as when everything is said and done, what you propose is equal to or less than what the standard reference design is, then it is deemed to comply and you met the criteria of it and you got some built-in flexibility for a lot more things than just the attic concept. So in this one, this is the one prescriptive option that does actually require a report. So you should get a res check or, have a res check or a report through Ecotrope or a report through REMrate. Those are the three that I typically see. Now, in this particular compliance pathway, you're still doing everything kind of by the book, what's in there. It only allows for that flexibility of trading items in the thermal envelope that you find in table R402.1.2. Now, the other thing is just realize that whatever you have within that report, whether it's res check or other, really needs to be able to match what's on the plans and also be on that manual J. I have found that a lot of times that's where this compliance path kind of has a few issues, a few hiccups that happen down the road on things. So I just bring that up here so that everybody is aware of it. Now, I just wanted to check, anybody have any questions concerning the prescriptive path, because we're going to move on to the fun and exciting next compliance path. All right, let's dive into the fun and excitement of the total building performance. So this is one that typically what you're going to have for this, it's again that concept of twin building concept, but the overarching deal with this is that you are looking at how does the house or building perform as a whole compared to just trading off components of the thermal envelope. So there is a little bit of trading that can happen with this, but it's a table that's going to determine what you can trade and how it should be entered within the software itself. But you are going to have that twin building where here's your reference design, here's your proposed design. You're going to have two reports that are provided, one that's going to be at plan submittal, and then a second report that needs to be provided demonstrating whatever was installed into the structure meets the criteria, and that's what you get to be able to get your certificate of occupancy. Now, the verification for this is done through an approved third party. So it is an outside entity that's going to look. I know sometimes there is some confusion about this, but just so that everybody's aware, what they're going and doing is they're either designing everything for the submittal or they're trying to get the report for the CO, and all they're doing is documenting what they see. So they're not going out there and performing inspections. What they are doing is, if the builder was supposed to install an R20 and they installed an R13, they will put in their software installed an R13 and, you know, the grade and all that fun stuff. So they're just there verifying, you know, what happened out in the field, not necessarily doing the inspection for it. But to be able to determine whether you comply with this particular compliance path, it's based off of your annual energy cost. That's going to determine if you meet the criteria for it. So again, how it works is we have our reference design, we have our proposed design. So in our reference design, you're going to follow what we find in table R405.4.2 parentheses 1. And what you do with that is you put that in for your reference design. And then in that same table, it lets you know how you install it for your proposed design. So you're going to say, hey, I'm going to do it as XYZ. And that table lets you know what you can and cannot trade within the design of the system. Now, in the 2021, in the past, there was notations on sections that said whether or not this was a mandatory section, whether it was a prescriptive section, right? In the 2021, all of those notations went away. But in this compliance path in 401.2, it states, hey, you got to comply with R405 if you're going to go with the total building performance path. Well, to ensure that you are not missing out on all of the fun and excitement of the sections that were considered to be mandatory, there was a new table created. And that is table R405.2, which is the mandatory table. So everything within that table is still required to comply with for a project, instead of where prescriptively it's all those sections that are listed there. All right. So some of the things to be aware of is for this compliance path, while I said it's the building as a whole, when it comes to how we determine compliance for it, the analysis includes your heating and cooling, mechanical ventilation, and your water heating energy. It does not include things like lighting or solar or other components. So these are the three things that we are going to determine whether or not it's compliant. Now, as I mentioned, there's the table that you still have to comply with that's considered the mandatory table. So here's an example of, you know, what you would find. You still have to do things like air leakage testing, you know, install eave baffles. So those items haven't changed. They might not be quote unquote listed as mandatory, but they are considered mandatory because of what this table shows for it. Now, the second part of our performance compliance is there is a backstop that's placed in here. And basically what they're saying is there are some concepts that are forever, no matter which compliance path that you utilize. And it's the concept that the thermal envelope, whatever goes in there as it's being built, probably is always what it's going to be, unless for some reason, you know, there may be an alteration or something. So the thermal envelope is one of those areas that there's no messing around with, I guess you could say. And so the backstop that's in here that says you can trade things off, but you can never trade the thermal envelope below the values that are listed in the 2009 IECC. So if we took a look at what we have in here, there's a few things, right? We could never trade our fenestration to be anything more than a 0.35. We can never trade our ceiling R value down to anything below what's a 49, right? So these are the values that they're saying when it comes to the thermal envelope that you can't trade it off. But remember that there's more items that you get to trade than just the thermal envelope. The third one is basically how do we demonstrate compliance? And that compliance is showing that the annual energy cost of what you're proposing to do is equal to or less than what the standard reference design is. And because we're talking about energy cost, there is a section in there that talks about where you can get those values. So you could get it from the Department of Energy. It could be Energy Information Administration for the state energy data system prices. It could be expenditure reports. It also, whatever is utilized is something that the code official is going to approve that source. So a lot of times when I get these, because we're in Excel's territory, that it'll show Excel's energy prices in there, and they're often, readily accepted with it. Now, there is an exception in here, and it does talk about you can utilize that your energy use can be used, but at that point, then you have to include or do more math that's going to include things like the multiplier. So if you utilize electricity or you utilize a fossil fuel, you're going to have different multipliers with that. Now, I mentioned you have a lot more options of items that can be traded off with this particular compliance path. So as you can see, all the items here that are in pink are items that would typically be associated with the thermal envelope and insulation, something that I would say is often thought about, right? When you're thinking about res check, you think about foundations, you think about opaque doors and how you're going to treat all that. But the items that you see in the other colors are not items that can be traded with res check or, the total UA option. So this is where you have a little bit more like your air leakage rate. If you happen to have a better air leakage rate, you could trade some of that off compared to other things. The mechanical ventilation rate, your internal mass, your structural mass, your heating and cooling systems, your service water heating, your thermal distribution system, your ductwork, right? Your thermostat. If you had a dehumidistat, then you could trade off components within that. So as you can see, this is kind of looking at that building more holistically as opposed to just focusing on the thermal envelope here. I had something I was going to talk about this, but it just completely went out of my brain. So we'll move on. I'm sure it'll come to me at some point. All right. So the table that includes all of these items, building components that are allowed to be traded are in this table. So how this table works is you have your building component as the first column. So in the first one here is above grade walls. The next part or the next column is your standard reference design. So these are the values that get put into your standard reference design that you have to demonstrate that your annual energy cost is equal to or less than of it. So this tells you what you're going to do. So how it would work is for our above grade walls, it says, if you're using a mass wall, then you're going to put in your standard reference design a mass wall, but otherwise, how it's going to be listed is going to be a wood frame wall. The next component that gets into it is your gross area. Now, this is going to be the same as whatever you're proposing, because the idea is, remember, geometric twins of each other. So if there's 100 square feet or gross area for your above grade walls for your proposed design, then it's the exact same thing that you're going to put in for your standard reference design. Now, the next one would be your U factor, and that U factor is going to kick us back into table R402.1.2. So remember that that was that 0.045. So that's the U factor that's going to be listed here. It's also going to include your solar reflectance. The number that's going to be listed here is 0.25, and your admittance, which is going to be a 0.9 in here. Now, the last column of this table is your proposed design. And typically, all the ones that are here, if they say as proposed, that means that you get to trade it. You get to do whatever you're wanting to do with it. If you came across something that said as the standard reference design or something, then it means that it's a component that is not permitted to be traded. But typically, just about everything in there is as proposed for it. So this is all done in the software, but just so that there's an understanding of kind of what's happening in the background of the software. For our standard reference design, we're doing wood framed. It's 1,000 square feet of gross area. We're going to have an R20, but that R20 is going to be what's listed in that table. So R402.1.2 is the 0.045. And then you're going to have solar reflectance of the 0.75 and what the admittance was, which is 0.9. Now, what you're wanting to do here is you have the same wood frame. It's 1,000 square feet, but now you're going to install an R15. And that gives you a 0.066. You're doing a solar admittance, or I'm sorry, solar absorption of 80 or 0.8, and then admittance of 0.85. And that's what goes on in the background of the software. And then ultimately, when everything is said and done, you get a compliance report. Now, your compliance report, you have to have one for your plan review, that permit submittal, and then you also have to have one submitted that says, hey, I comply, and then it has to be provided to be able to get a certificate of occupancy. Now, what's required, there's specific items that are required for each of the documentation, the report submittal. So the first one is we have to have the building address, right, or whatever's going to identify it. Whoever performed the analysis, the name and version of the compliance software tool. Then we have to have documentation of what all the inputs that were put in for the reference design. And then we also have to have a certificate. The certificate's going to give us a whole bunch of required information that's on there, which works out really well because if you recall, we also have to have a certificate placed on that electrical panel. So this takes care of that for you. And then number 6 is there. So, a lot of times we do master plans, right? And so number 6 says, basically, if you're going to do a master plan, here's kind of what we're proposing for it. But what it states in 6 is whatever your worst case scenario is for the orientation. So each orientation is going to have a different outcome for it. Whatever your worst case scenario is, the one that needs to be submitted for the plan review. So basically, we're saying, hey, no matter what direction, it's good because here's the worst facing what our values would be. Now, when it comes to what's required for the certificate of occupancy report, it's very similar in the fact that, the building street address. We have to have that the total building performance is on the title page of that report. There has to be the name of whoever did it, the name and version of the software, site-specific analysis of the report, the final confirmed certificate, and then if you happen to utilize on-site renewable energy included in it, then we have to have a certificate that's going to report the type and production of the installed system. So here's a report, just kind of going over it, really briefly. Here's an example of where we would find the information. This happens to be Ecotrope. This is where we find the information for the address, where we find the name of the individual who performed the analysis and generated the report, and then where we would find the name and version of the compliance software. This one is Ecotrope. REM rate is fairly comparable. It's not exact, but it is fairly comparable. And then documentation of all the inputs to the software for the standard design or standard reference design and what you're proposing. Here's an example of that. Our compliance report for the certificate. Here's an example of the certificate that we would get. And then if it's a master plan, remember we have to have, worst case scenario for it as far as the compliance. So here's an example of a report. Which row am I looking at to demonstrate that this project meets the criteria?
The bottom half of the page?
Are you down here? Is that what you're referring to? Oops.
What are you down? Oh, no. Yes, that's what I'm referring to.
It does help. It is a quick glance at, because you can see that it says it, and if it doesn't comply, it'll also say it doesn't comply. So that is a good one. But just as a rule of thumb, remember at the very beginning when I was talking about this compliance path, to demonstrate compliance, all they're looking at is the heating and cooling, your water heating, and your mechanical ventilation as far as your annual energy costs. So what you're going to look at is this row right here, the subtotal. It's very confusing, but the subtotal is the line that demonstrates whether you meet this criteria or not. The bottom one includes the on-site renewable energy and lighting, which is not part of the criteria when we look at the scoping. So
I have a question.
yes, absolutely.
Has anybody done this yet? I got my first inspection today by Gary. He's asking for this. And so do we get this reviewed or inspected as we go along? I mean, I know we have one initially when we submit the permit application, but then who verifies it at the end? I mean, I got a blower door test, and all this stuff, but how do we get to this?
Yeah, so typically what you would have is often whoever is doing your blower door test probably has the software for this and may have done it, but this is verified by a third party. So you would have an outside entity that is coming out and verifying whatever was installed in the assembly or the mechanical equipment. All of that would come into play, but it's verified by a third party. So it's not something that the builder would do. It's not something that the code official would do. It's done by an approved third party, which would be approved by the code official if there was questions on it.
And so they're doing this as you're building. It's another inspection that we have to do during the process.
I thought previously you said there wasn't, they wouldn't be doing other inspections for this, but then they have to testify that It's been done, like,
Yeah, so it's by code, it is required to be verified by a third party. So it's not the inspector going out and inspecting it that's documenting it. They're going out and inspecting it for their documentation. A third party is going out and just verifying what was actually installed as far as the project goes. And that's the inputs that get put into this particular report.
How far along are you?
I'm done. I'm like, he's like that.
So then you would have your energy compliance, your energy costs on all of your, your heating, water and cooling. So you'd have all that. So then you just have to get somebody to generate the report, but they
Yeah,
don't come, yeah,
so it's just those main items, but the assembly itself
that's not what they're asking
is
for.
less, is not what
that's
you're
what
asking.
you're using that
That's
method.
what
too.
Yeah.
So 3 different methods you can use to get to where you need to go.
This would only be to inspect your heating and air conditioning.
Yeah,
And
it's just the EUA.
Yeah.
It's not the building envelope.
And that's only if you're using the performance path. So whoever, I guess.
But they are going
How it was permitted.
It's time to figure out which path.
They would actually come to the site though and visually see your equipment.
Yeah,
So it could be the same guy that's doing your blower door.
It's usually the same as the blower door, so lots of them do all umbrella over the whole thing to cover everything.
Okay,
Yeah,
So you're
typically
doing-
they'll go out multiple times and
You're doing the tour
verify.
EUA, you're not doing prescriptive or anything, you chose this path.
I did, I have to ask Sarah, but I think she chose the prescriptive path. Because
Then you
most people
wouldn't
don't
need
want
this.
to go through this,
Yes, you wouldn't need this if it's prescriptive.
but that was. Yeah,
Yeah.
right.
If you went prescriptive, this is not a criteria. If you went prescriptive, then yes, the inspectors are going out verifying that whatever was on the plans is what was, installed out in the field. You would have, a third party coming out doing like your blower door testing and your duct leakage testing, but the third party verifier is specific to this particular compliance path. So if you went prescriptive, you would not have to have a third party provider verifier on it.
Thank you.
Yeah, absolutely. I am glad you're asking your questions. Any other questions on this particular compliance path?
I think we're good here.
All right. Okay, so now let's go ahead and I think whoever is listed as MC, you lit up, and I think you were trying to talk, but I could not hear anything. If you have a question, you might want to put it in the chat. All right, let's talk about the energy rating index. Now, this again is, as I mentioned, it is similar to something that we have used in the past, which is that HERS score. Now, when the ERI path came into the code in the 2015 edition of the code, HERS and ERI were one and the same. In the 2018, there was a divergence because of the ventilation calculation. In the 21, it's even further divergent. So the ERI and HERS score are not one and the same anymore. Now, the reason why in this energy code, it's called the Energy Rating Index is because ICC does try to be non-proprietary. So if there was another system out there that was XYZ index, but met all this criteria, would be something that you could utilize with it. But this one is, again, the idea of that twin building concept. So in this instance, the reference design building happens to be the prescriptive values that you would find in the 2006 IECC. And then there's a number that is shown that demonstrates compliance. And basically that number is showing how much better it is than if it was done to the 2006. In this pathway, it is specific. There is some very specific criteria when it comes to the thermal envelope, because again, the idea is that the thermal envelope is a more permanent part of the structure and it is not often altered typically. And so because of that, they really did emphasize and ensure that the thermal envelope is a strong thermal envelope, no matter, you know, if using this pathway or not. Now for this one, some of the items that are part of it and hit into it is the sheer fact that there's two options within this. So like the prescriptive that had 3, there's 2 when it comes to the ERI, and it's dependent on whether or not you have solar for it. Now you could have solar and not included in your number, but if you have solar and included into your calculation, then we're going to have to follow different criteria for each one. So when we're talking about the 21, there are some things to keep in mind, right? We have to comply with table R406.2. And again, there is a treatment of the thermal envelope depending on whether or not you include on-site renewable energy with it. Now, ultimately, it's table R406.5 that determines whether or not you are compliant with the code. And then just like with the total building performance, 2 compliance paths compliance reports are required. One is going to be required at plan submittal. And then the second one is going to be required to obtain a certificate of occupancy. Now, again, this one is not going to be verified by the code official. They're going to still go out and do inspections per, code and everything. But as far as demonstrating compliance with what's inside the report, there's going to be an approved third-party verifier that's going to do that. And then within the code itself, there are very specific parameters as far as the software tools that can be utilized, and then also some criteria for if you're utilizing renewable energy certificates, those RECs out there. I saw a question pop up, and I'm going to try to get it to pull up here. Yay. All right, so the question is, does this apply if you are making the home solar ready versus installing solar with the initial build? That is an excellent question, because we do have, solar ready provisions and everything. But what this is referring to is if you have the actual system in place. The intent is not in a future date, maybe you have it, but the intent is, we're going to install it here as soon as the roof is on, type of deal. I hope that answers your question. Perfect. Glad you're asking your questions. I love questions. All right, so here's the idea here, right? Geometric twin, no matter it's the same building, whether you're going the reference design or it's whatever your desire is for it. The reference design is going to have all of the 2006 IECC prescriptive requirements. Now, a lot of times people focus on things like the thermal envelope, which is a huge component. But remember, this is talking about the 2006 encompassing the prescriptive requirements. Now, in this instance, you're going to include, or for the design, the desired house, the proposed house, you're going to do whatever it is that you want to do. Now, again, when we talk about table R406.2, that's referring to the mandatory table. And then ultimately, to determine the idea of whether or not you comply with the code is you're wanting to achieve a good number. And that good number is whatever number is listed in that table. All right, so the very first thing when we go into C40 or R406.2 is what do we have to do to demonstrate compliance? Now, one is you're going to have to include the parameters that we find within table R406.2, which is our mandatory table. So that means you are taking all the criteria that you see here and ensuring that it is actually being installed in or designed into the project. So no matter what, the sections that you see on the screen are the sections that every project is going to have to comply with, no matter whether you're going prescriptive or you are going with any of the other options of the residential compliance paths. So the next part is letting us know that whatever we do, we have to demonstrate that we comply and that it meets a number. And so this is where we're going to look at table R406.5. Now, R406.5 is this lovely table that tells us that we have to get an ERI score that does not exceed the number that is listed on the screen. So for climate zone 6, we would have to have an ERI score that is a 54 or less. Now, with that being said, we're going to come back to this and have a slight little discussion about it. Now, what 406.3 tells us is if by chance we are going to not include on-site renewable energy into our calculation to obtain this score, then what we get to do is it's a, I want to call it, it's a bonus. And what you get to do is instead of having straight out values that we find in table R402.1.2, which is the U factor table, now we get to take that table and you get to, I don't know if you get the, the increase of 15%. So now you're going to multiply it by 1.15. And if I was really good at math, I would do that for you. But let's face it, if I didn't have those slides earlier, I would not have been able to do the math. But the idea is you get a bonus for not including on-site renewable energy for it. And this is done within the background of the software too. Now, if you're going to include on-site renewable energy into trying to obtain this score, now what you have to do is you have a different backstop for your thermal envelope. In this particular backstop, it says you cannot have values that are below the 2015 IECC. So again, it's things like your glazing couldn't be below, I think it's a 0.32. Your insulation couldn't be less than a point or a R49. So there are things in there that you just are not able to reduce your thermal envelope is, because the idea for this and the big concern is they didn't want the thermal envelope to be traded away to just install solar. So they were trying to be very conscientious of that concept. So 406.4 really is letting us know, okay, you're going to get an ERI score. That ERI score is going to be determined utilizing the standard ANSI ResNet ICC 301. Now, this is where the concern is. What is in here? states that you cannot use the ventilation rate that you find in ANSI ResNet ICC 301. You have to use the equation 4-2. And this equation is only utilized if you're going to go with that ERI score. It also says, hey, by the way, EV charging stations are not to be included in the calculation for that ERI score. As long as it's, used on, it's going to be used on roads off site, right? So you have an electric vehicle, obviously you're going to use it off site. So that is not going to get included into the equation. The other kind of quote unquote backstop in this option when it comes to, it says on-site renewable energy, is the fact that you can only utilize up to 5% of whatever the production is going to be with whatever the on-site renewable energy rate is. So again, all of that lets us know that once you use whatever equation you're going to need to utilize at that point, as long as you are at a 0.5 or have an ERI score of 54, then you are going to be able to demonstrate that you comply with this code. Now, as I mentioned, there are 2 reports that must be provided for this compliance path, one at plan review, and at plan review, it's very similar to the items that we talked about for the performance path. We need to know that it is where it's going to be, right? What's the address? What's the building site identification? It also has to declare on the report that this is an ERI, and that has to be placed on the title page of the report and also on the building plans. This is important because the same software that does the total building performance is the same software that does the ERI report. And so they look very similar. And sometimes it's hard to determine which report is going for which compliance path. So now the code says, you know what, on that report, it has to say that it's an ERI report. We then have to have the name of the individual, the person, or the name of the and version of the software that was utilized, documentation of what was inputted. We also have to have a certificate with all the information that's listed in 6. And then 7 is talking about when you aren't doing that site specific because you're doing a master plan. That's fine. Just give us the worst case scenario for whichever orientation is the worst producing ERI score. And then for the second one, the second one is for the certificate of occupancy. It's very similar to what we saw for what's required for the plan submittal. The only real difference here is basically stating you don't have the worst case scenario because you will have to have an actual site report for the site. So a third-party verifier is going to go out and do it, where you might have a master plan at plan review. They're not accepting a master plan for the certificate of occupancy. At the certificate of occupancy, we have to have a site-specific report. And so the report here is going to show us what our numbers are. And so here's our ERI score. On this particular report, it says ERI with solar is an 81, and down here, ERI without solar is an 81. So as you can see right here, it says it does not pass, just in case anybody had any questions, because 81 is greater than the 54 that is permitted. And then also you can see here that it talks about, here is an energy rating index report, meeting the criteria of what it has to have. Any particular questions concerning this compliance path?
Oops.
Okay, go ahead.
Go.
Is when we're doing an addition onto an existing structure. Where does the new compliance schedule end?
So the new, Hope, do you want to answer that? Sorry.
Oh, no, go ahead. I, I'm not sure
Have
how you're addressing it, but chapter 5 takes precedence on how you deal with it, because chapter 5 is, was developed for existing buildings. Now, when we're talking about an addition, it does give you some option. Now, the ERI path is not necessarily included in the 21 as demonstrating compliance for ERI, but the addition can have the ability that you can show compliance with the addition alone or the addition and the existing building.
Yeah, that's the point of the ERI and versus like,
Any method picked in the design of that addition. You can still use any either.
what would be the advantage of this over performance or one of these other ones? The ERI.
As far as the ERI goes, it kind of depends on, really where your goals are. There are a lot of communities that really like utilizing the ERI path because it's a great option if you are trying to get to net zero energy. And so this is one where they can do it, because where the number would be 54, it gets reduced and saying, okay, you know what, now you have to get a 47 before you install solar, and then demonstrate with the solar that you're at zero. So this pathway is often utilized and referred to when it comes to communities that are working towards net zero.
So once again, and this is probably just because I'm not totally understanding, these three paths are going to be selected by the designer of the building.
Mm-hmm.
So we as builders, unless we have worked with the design of the building, really don't have a choice which one it's. We are just building what they are giving us.
Exactly.
So we can't choose. It's,
I was gonna say, unless something gets screwed up and then you have to like change it at the end.
Only if they screwed up, then it's your.
Yeah, I
It's
mean, you really
clear.
hit it on the head there. Oh, sorry.
mm,
Can you say that a little louder, just so?
Just to be clear, following the prescriptive path always works, no matter what.
Will all always work.
But in this case, the designer follows the ERI, and then the reality of building the thing, it's like, well, that doesn't actually work. As long as when you actually build it, you go with a prescriptive path, then you could
Yeah, they
apply
have
with the
to,
code.
If they would have like the must insulation or something, then maybe you change it at the, I don't know.
you would have to do a plan change with a whole new energy design. You have to meet the energy set. You have to read the plans.
Yeah, that's what I'm saying, like, anybody can change at the end or something.
Right. But yeah, if you were gonna change the whole, if you're gonna change a whole different compliance pathway, you'd have to do a whole plan change. And all that it meets the code, that's compliant with the code for that compliance path. So best to just do whatever they design.
and hope they did it right.
Well, we're on their time to review for that.
Yeah, no, I understand.
I know there's still holes in the system, but we'll get there.
Right.
Baby steps, right? We're building on top of it. This is, I know most people say, why would you say this, Hope? But sometimes mistakes are great because they're a great opportunity to learn from it. And a lot of times when I make a mistake, I only make it once, right? Hopefully I only make it once. So not that I'm advocating go make a mistake, but if you do.
Hey, can I ask about the air exchange test and so on at the end of the project? Right, is there a better time to do this midway through this project to make sure that you're on track to meet this and not at the end of the project, do you?
So it's once all the penetrations in the thermal envelope are sealed, you can do it anytime.
At the time,
So
so
you can do it
prior
before.
drywall and all that stuff, you can.
I know a lot of people like to do it prior to drywall because sometimes if you're including duct testing in there and you have like a leakage in a duct, or you have a chance to fix what's leaking.
Sure, so boom, so not to wait till the end.
Yeah, and one thing with that too is that's where you're going to want to make sure that you're looking at the plans, because there are some designers that call out that they're utilizing the drywall as their air barrier. And so if that's the case, then doing a blower door test before the drywall is up will potentially make it so that you aren't meeting your blower door test, just as a FYI.
Yeah, for an example, I've seen one where they used the ceiling drywall as the barrier, so they had just that installed, had the walls just insulated and sealed, and then they did the lower door because they had that barrier.
Okay.
Great discussion, everyone. This is wonderful. Now, this is a section that just to make sure everybody is aware of. Your compliance path kind of has an effect on a few things. One is you'll notice in 401.2, it says, hey, you got to comply with section 401.2.5 and one of the four that are listed there. 401.2.1 says the prescriptive path. 401.2.2 says the total building performance. 401.2.3 talks about the energy rating index. And unfortunately, our 401.2.4 doesn't pertain to Colorado because it's the tropical zone and we might be a desert, but we don't have tropical features with it. So when we look at 401.2.5, it states we are going to have to do the additional efficiency requirements. Now, if you're going prescriptive, what you're going to do is you're just going to pick one of the 5 options that are in here. You can have a better and a more enhanced thermal envelope, which probably is going to, I'll be honest with you, is a difficult one to be able to achieve just because everything was increased. More efficient HVAC equipment, reduced use in your surface water heating equipment. Probably the easiest one is putting all of your duct work inside the thermal envelope. And then the last one is where you do a combination where you do a blower door test that's less than the 3 air changes, and you put in an ERV, HRV system. Now, remember, that was if you are going prescriptive. If you're going with the total building performance, you can either do where you pick one of those additional efficiency packages that I just spoke about, and then not include it into your calculation of the proposed design. Or what you do is you can include it in it, but then you're going to have to demonstrate that instead of it being equal to, or your annual energy cost being equal to or less than, now you're going to have to demonstrate that your annual energy cost is 95% or less. Now, if you're going with the energy rating index, in this particular instance, what you're going to do is demonstrate that that number of 54, instead of getting the number of 54, now you have to get a number that's 5% less than what you would find in the table. So you would obviously have to do 0.005, multiply it by the 54. And I am not that good in math to give you what that number is. It's probably like 51 as the new ERI number that you would have to get, because I know 55 takes you down to 52. So I'm guessing that 54 takes you close to 51. So this concludes the residential portion of the compliance paths. I didn't know if there were any other questions concerning this.
Do you go back one slide?
Absolutely.
So what's considered efficient HVAC?
Yeah, so if we went into that particular section, what it does is, I'm going to pull it up here, is for your HVAC equipment, it's talking about you would have to demonstrate that if you were having a natural gas furnace, that you are at least 95 AFUE or better, and that for your air conditioner, it has to have a SEER rating of 16. If you're going with an air source heat pump, you have to demonstrate that it's at least 10 HSPF with a 16 SEER or better. And if you're going with a ground source heat pump, then you have to demonstrate that your COP is at least a 3.5.
And then same with the service, do you have to be like a air source heat pump for the water heating option?
It's a little bit different for the water heating option. So if you're utilizing fossil fuel for your water heating system, then you have to demonstrate that at a minimum you have an 82 EF. Now, I know that when this code was developed, the new metric was not in place, so it would be an 82 UEF because you wouldn't see EF anymore. And then if you're doing an electric service water heating system, then you have to demonstrate that you have at least a 2.0 EF. And then if you are utilizing solar fraction solar heating system, then it has to demonstrate, or you have to demonstrate, if you're doing a solar water heating system, your solar fraction rate has to be at least a 0.4.
Right.
Pretty specific. Yeah.
All right. Any other questions? If not, I'll move on to the commercial.
I think we're good here.
All right. Let's talk about the commercial provisions here. So when we talk about commercial, it might look a little familiar because there's a lot of concepts that, you know, are pretty comparable. You have the prescriptive option. In that prescriptive, you have 3 options within it. You have the total building performance compliance path. And then you have the third one. Now, the third one is a separate standard. It's a completely different book, and it's ASHRAE 90.1. So you could choose to utilize the IECC for your commercial project, or you can go into a completely different standard, energy standard, and utilize that. Now, in the past, what determined what compliance path would be utilized for a commercial project was the mechanical engineer decided which path a project would utilize, because depending on the mechanical system itself. Now the IECC and ASHRAE are almost a carbon copy of each other. So you find more commercial projects that are going with the IECC because it addresses those complex mechanical systems. Just a brief overview on why that is. All right, so let's talk about the prescriptive path. So in 401.2.1, it says you got to comply with one of the following. The first one is the prescriptive path. That means you're going to comply with 402 through 406 and C408. And it also breaks out R2 buildings. Now, because R2 buildings typically are multifamily, right? So if a system, it happens to be an individual system and it's not for multiple items, multiple units, then you can utilize this particular option with it. And then you're going to have to comply with C406. Now, in this one, the insulation and fenestration criteria does happen to be the R value, whereas residentially, the insulation and fenestration criteria was the U factor. So I just want to make sure that everybody understands they're kind of separate in this one. But commercially, if you're going with this option, you have a few tables that you're going to follow. And this one, again, is really by the book. Tell me what to do, and that's what I'm going to do. And the tables that we're going to look at is you're going to go into C402.1.3, and that gives you all the R value options or R value criteria for your thermal envelope. Then you're going to go into table R402.4 for your fenestration maximum values that you can do. Then you're also going to go into table C402.5.4 for your air leakage rates that are allowed for your fenestration. So those are the three tables that govern really this compliance path, particularly as it's looked at for the thermal envelope, because just like residentially, the prescriptive path, the three options that are in there, the only real difference on how you're treating them is the thermal envelope components of it. So this is the R value table that you'll find. And as you can see, here is the column for climate zone 6. And everything that you see in blue is new for the 21, but all of it is really kind of comparable to what it has been in the past. Here is the U factor and solar heat gain coefficient table. So in this particular table, whether the fenestration is fixed operable or it's an entrance door, these are the numbers that we can't exceed as far as the U factor. Now, when we talk about the solar heat gain coefficient, it is dependent on whether or not it's fixed or operable. And then it's also dependent on what the projection factor is that lets you know what values. And then we have our skylights, and our skylights, just what the U factor and solar heat gain coefficient is. This is the table that shows what the maximum air leakage rate for the fenestration assemblies actually are. Now, this compliance path, again, you're not doing any trading within it. Everything is done by the book. There are no specific reports that are required for that thermal envelope, but to help demonstrate compliance with the code, you can get and require a mechanical compliance certificate, interior lighting compliance certificate, and exterior lighting compliance certificate that's provided by ComCheck to help demonstrate compliance with this. So again, you're going through section 402 through C405. You're going to do the additional efficiency requirements that are in C406, and you're going to comply with C408, which is the commissioning part of it. The next one, which is the alternative option, is dealing with the U factor, C factor, and F factor option. So our U factor is dealing with heat transfer from through an assembly, side to side of an assembly. Your C factor is the component that you're going to look at as far as that's not what I wanted. Your C factor is dealing with how you're determining for your basement walls, below grade walls. And then your F factor component is talking about your slab on grade floors. So those have different concepts behind them. So again, you're going to do table C402.1.4. That's the table that governs the U factor, C factor, F factor. You're going to do C4024 for the fenestration, and then you're going to go into C402.5.4 for that, the maximum air leakage rates that the fenestration can actually have. This approach, again, is not utilized very often. It was prior to the addition of the 2015 edition of the IECC. And that's because there was no component performance alternative option for commercially. So you couldn't use ComCheck. ComCheck was a accepted alternative approach, method and material approach to compliance. So a lot of times this was the option that was utilized, but it's not utilized as much anymore because we have software that'll do all the math for us. Here's the U factor table. Again, the fenestration table and the air leakage table. Now this one, again, we are not going to have any trade-offs for that thermal envelope. You're going to have everything on the plans. It's by the book. The only kind of documentation that's needed is that we do have to know where you got your assembly values, your R values, your U factors, right? That get put into that U factor concept. Again, you can go into ComCheck, get the mechanical and the lighting compliance certificates to demonstrate compliance with those sections. You're doing 402 through C405, and you're going to do 406 for the additional and 408 for the commissioning on this. Now, this is the fun one. This is the one probably most commercial projects actually utilize because it allows for trading of the thermal envelope. And again, this is where ComCheck comes in. ComCheck is the only software that I know that is doing this. There may be other software out there, but it is the software that I see with it. It allows you to trade the thermal envelopes. What governs what's traded is what you find in table C402.1.4. Those are the calculations that go into it. Again, this is that twin building concept. So you have your standard reference design, which is the values that you get out of table C402.1.4. Then you have your proposed design, which is whatever it is you would like to do within the thermal envelope itself. And I would say, like I said, this is used more times than not, especially with the new criteria that's in there for the thermal envelope. Now, obviously, this one does require that a report be provided for the thermal envelope to demonstrate compliance with the thermal envelope, because this only pertains to the thermal envelope. You still can get the mechanical and lighting compliance certificates, to show those. This again is by the book. Everything is on the plans for it. You're complying with 406 or 402 through 405 and 406 for the additional efficiency requirements. And you're going to comply with 408 for commissioning. Now, I do want to bring into the conversation about the additional efficiency requirements. And what this is requiring now is you will have to obtain 10 points when you are a new building. And when you are a tenant space, it's 5 points. Now, it's not spelled out in the code, but when we talk about a tenant space, that is the first tenant that goes into a project. So if you have a core and shell, that core and shell is getting 10 points. When the tenant goes in, they are getting 5 points. If it's an alteration, they follow the criteria that's in chapter 5 and not necessarily getting the criteria of the 5 points. Now, there are a plethora of tables. I believe there's 9 tables here. All of the tables are set up per occupancy. And then within the table itself, it has the components that you get to choose from to get to the 10 points. And then you also have the how it's weighted per the climate zone. So if you were in, climate zone 1 and you had really efficient heating equipment, you wouldn't get any points for it. But if you had really efficient cooling equipment, then you would get more points for it, because obviously, they weighted it per the occupancy and weighted it per the climate zone for it. Just so you know, in most instances, you will probably have to do multiple requirements to get to the 10 points. So it is going to require that there be more conversation and probably more planning on things at the design phase. So your options here, when it comes to what you can do, there are 11 items here that you can utilize. Now, not all options are available for all occupancies, but you do have 11 that you get to choose from for your project. Now, this only is required if you go prescriptive in the commercial compliance path. All right, let's talk about the total building performance. In this particular instance, C401.2.1 says, if you're going total building performance, then all you have to comply with is what is found in section C407. Now, C407 is that concept again of we're going to have twin buildings. So you're going to have a building for what your reference design is, and you're going to have a building of what you want to do. And there are multiple tables within this compliance path that's going to tell you what is allowed to be traded, because just like residential for their total building performance compliance path, you have a lot more items that you can trade beyond what's in the thermal envelope. Now, in this instance, it does have the annual energy cost is going to determine compliance, and I'll get to how that is actually determined here momentarily. So the first table that we're going to look at happens to be the mandatory table, and this mandatory table is going to tell us all the sections that prior to the 21 were labeled as mandatory to ensure that even if you go with this pathway, you still are meeting the criteria, such as, testing your air leakage, all that fun stuff. In number 2 of 4072 says to demonstrate compliance, you have to demonstrate that your proposed design is 80% of what the annual energy cost is. So basically what they're saying is your proposed design has to be 20% better than if you were building it to the reference design. And that's found here. It shows it here. It actually calls it out in these reports in multiple locations. So these are all the items that are permitted to be traded within this compliance path. You see, there's a lot more than than just the thermal envelope, right? Your lighting can be traded, your mechanical ventilation, your mechanical equipment itself, your surface water heating, all of that can be included into the calculation for your compliance. Now, I didn't go into the table like we did before because we talked about it residentially. It's the same sort of concept, right? We're going to look at the building component, the standard reference design here. All the information here is what's going to be put into the software as the reference design. And then you're going to put in the values of what you're proposing to do. And then ultimately, when everything is said and done, if your proposed design is 20% better than what the reference design is, then you're deemed to comply with this particular compliance path. And so with this, there is specific criteria of what the compliance report has to demonstrate. And this is only required to be provided at plan review. There isn't a second report required on the commercial side as there is on the residential side. But it's also kind of taken care of because of some of the commissioning that's involved with it. But in this, the compliance report has to have the address of the building. We have to have what's called an inspection checklist. That inspection checklist provides all of the information about what was proposed in the design to ensure that, basically there's every opportunity that out in the field we're going to get it. It's got to have the name of whoever created the report and then the name and version of the software that was utilized. So again, brief oversight of it, 80%. You can't exceed 80%, so it's got to be 20% better than whatever the standard reference design is. There's several tables that you have to utilize, including the mandatory table. And then we have to have a compliance report provided for this pathway at permitting. There is specific criteria of the software that's utilized, and you'll find that in C407.5. And then, of course, commissioning is required with this pathway. And last but not least is ASHRAE 90.1. Now, the big thing for this one is if you choose to go ASHRAE 90.1, you are doing your entire design to ASHRAE 90.1. You can't pick and choose saying, I'm going to do the thermal envelope of the IECC and then ASHRAE for mechanical and then come back here. There are some areas where the IECC is more stringent, such as the additional efficiency packages. That's not a criteria out of 90.1. But then there are provisions out of 90.1 that are more stringent than what you would find in the IECC. So when everything is said and done, they're probably fairly comparable now as far as the energy efficiency goes. They're not duplicative codes and standards. But if you get a report, it has to say that they utilized ASHRAE 90.1. The compliance paths that you find in ASHRAE 90.1 are very, very similar to what you see in the IECC. You have the prescriptive, which is the 3 options, the R value, the U factor, and then they have the envelope trade-off, which is ComCheck. You have the energy cost budget, which is the total building performance that you find in the IECC. The one that it goes beyond that you won't find in the IECC is what they call their performance path. That's utilizing Appendix G. And that's when you're going with like a lead program where you have to have the base of the code and then you're going above that. You could utilize Appendix G for that. So those are the compliance paths for commercial. I don't know if anybody has any questions.
Yeah, I have one. So the ASHRAE 90.1 compliance path, how does that fit in? Is that its own separate compliance path or it fits into a different?
No, it's its own option. So you would have to utilize that book instead of the IECC for it.
But yeah, okay, all right. I was just kind of wondering, does it specify, and you said it's Appendix G, does it specify it there that you would use that?
Well, actually, if we went into, I'm going to jump back here, nobody gets sick, but if we went into C401.2.1, it actually has a section in there that says, hey, we will accept if you utilize ASHRAE 90.1 instead of the IECC, we will deem that if you use ASHRAE 90.1, you are deemed to comply with the IECC because most jurisdictions typically adopt the IECC and they're not adopting ASHRAE 90.1. So it's just giving a little bit more flexibility, but 90.1 has its own compliance paths that you would have to follow.
Gotcha. Thank you.
Yeah, absolutely. Any other questions? All right, well, if anything pops up because you're like, it's 5 o'clock and my brain isn't working any longer, but at 2 o'clock in the morning, you're like, did Hope say that? Reach out to me, write it down, send it to me. I won't respond at 2 in the morning, but I'll respond probably at 5 in the morning for you. So, but that's
This
it,
is
everyone.
great.
That's all I have.
Thank you so much, Hope. We really appreciate
Thank
your
you.
time.
Thank you.
Thank you.